so remember we did the square root function. We talked about inverses in an earlier chapter. So what is, or what undoes a square root?
A root. A square.
A square, which would be x squared. Okay, so x squared is a parabola. Now we know that when you have a square root, and you guys don't have to write this part down, you can just pay attention. When you have a square root, we've done this before as well, it's not a parabola. Think about what the inverse does. What happens with the inverse? There's a couple of different things. Part of it, yeah, part of it is undefined.
Oh,
It does. The beep, okay, is part of a parabola. Like if you turn it on its side, but why is it turned like that? What is the rule with all inverses?
It has to be special.
Okay, it reflects over the line.
X equals Y.
X equals Y or Y equals X. You guys remember that? Remember with all the points, what happens? Flips. X and Y, they switch. Okay, so this part here, we don't see that. Okay, we just see this part because you can't take the square root of a negative. So this part here is technically the negative square root of x. Do you guys remember what a cubic function looks like? Or, yeah, cubic x cubed. Yep. Okay, so if we have the cube root of x, we're going to see this is also a reflection. It's going to look like this. Or it'll look like this. Sorry, I guess it looks kind of weird to see them next to each other. And you think that they are together, but they're not together. So that's what we're going to practice graphing today, are the cube root and then the square root. We're going to do some transformations. And then we are going to continue working on the domain and the range. So the square root function is f of x equals the square root of x. We are going to make a table for that, starting with the lowest x value I could possibly plug in. What is the lowest x value you could possibly plug in?
0.
Is it 0 or 1?
0.
Ian, you seem very confident. Why can we plug in 0?
Because the square root of 0 is 0.
The square root of 0 is 0. And then the next one is going to be 1. The square root of 1 is 1. Okay, so Cam, if I'm doing this without a calculator, and I'm focused up here and not on my phone, I would know that my next value I want to plug in is what?
4.
4. Why?
Because it is a perfect square.
Yes, good. Okay, so then the next one I want to plug in, everybody, is 9. All right, these are the 4 points that I'm going to have you graph whenever we're doing a square root, okay? So anytime we do a square root, I'm going to have you use 4 points, okay? You can definitely do more. It's just I'm requiring those 4. The next one will be 16. So on and so forth. Okay, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. That's where we're getting our values. Okay, so now we are going to graph those. So I have my y and my x-axis. So this would be 2, 4, 6, 8. I'm just going to label that as the 9. Alright, so I have 0, 0, 1, 1, 4, 2, 9, 1, 2, 3. And this is curved just like you would curve a parabola. And you have an arrow on this end. You do not have an arrow on this end. Think about why that is. This is Yeah, because then your
It
x
doesn't
values would be
continue.
negative, and we can't take the square root of a negative, or we would get imaginary values. So you only have the arrow on this one end of your graph, okay? So now we're gonna talk about the domain and the range. So we know that the domain is going to be your input values or your x values. When we talked about domain earlier this year, we emphasized what are the things you need to look for. So there were fractions, and there were also what type of roots? Even roots. So if you have an even root, you can't take the even root of what?
Negative.
Negative number. So can't take the even root of a negative. So when we had to find the domain, we took the radicand and we set that greater than or equal to 0. Okay, so that means in this case, if you have x, yeah. Okay, so we're gonna write that in set builder notation. So x such that x is greater than or equal to 0. Okay, and that is your domain. Now your range is gonna be your set of output values or y values. So let's look at our y values, okay? What you're doing is you're looking vertically. The lowest y value we can have is what? 0. And then if we look at the arrow, is this gonna continue to go up?
Yes.
Yeah, sometimes it will continue to go up. If you have like a reflection, it will go down. Because it's continuing to go up, our range is gonna be y such that y can be 0 or above. So we would write that as y is greater than or equal to 0. Okay, so you're starting at 0, and it increases to infinity and beyond. Is that what you guys were saying in your head? All right, now let's talk about the cube root. So the cube root is f of x equals the cube root of x. And for this table, we are going to focus on 5 points. Do you guys think? You guys think you can tell me what 5 points we're going to focus on for the cube root, so we have a good
0,
picture?
1.
Yeah.
0, 1, 8.
Okay.
27.
27 is a perfect cube. 27 would be the perfect cube after this.
It'd be -1, -8.
Yeah, so we want to get a full picture. And remember, if you have an odd root, you can take the odd root of a negative. Now when we're filling in our chart, okay, what you're doing is you're actually taking the cube root of -8, which is what?
Negative 2.
-2. The cube root of -1, which is
Negative 1.
-1. Okay, so that's where these values are coming from. You are plugging them into your equation, and that's how we know those are our outputs. Okay, so there are 5 points that you should have on every single cube root graph that you do. Again, there can be more, but at the very minimum 5. So if you wanted more, like you could do 27-3. Okay? You probably want to scale by 3s, just so you can fit that on there if that's what you're doing. All right, so this is an odd root. So with an odd root, there are no restrictions. Okay, if there are no restrictions, what is our domain? All the numbers. Do you guys remember how we're going to say that?
X so that, X so that X is enhanced and all those.
Good job. Y, and then, oh, sorry. We'll graph it and we'll talk about the range. Just got too excited. We'll talk about why the range is all real number terms. Okay, so now we're gonna graph our points. So on my x's, I'm gonna have a point at 1, 1, 2, 3, 4, 5, 6, 7, 8. Who do we appreciate? Math, math. Okay, so when we graph this, I'm going to show you guys little tricks here. So we have 0, 0. We're at 1, 1. We're at negative 1, 1. See how you have like these 1, 2, 3 dots in a row? Okay, that's not going to be, it's not going to be a straight line. Okay, so we have 8 up 2. Negative 8 down 2. What this is a curve. So see how you have these 3 points here? This is really like part of a skinny parabola. So this is how we connect those points. And then we're going to do the same thing with this side. Boom. How'd yours turn out? Looking good? All right. So now we can see why the range is all real numbers. On this side, this is going to be creeping up to positive infinity, right? Slowly but surely. This is going to be going down to negative infinity. Okay, so eventually it'll span the whole thing. That's why we have all real numbers. I'm just going to show you, remember how we talked about with the cubic function, how it is a reflection? So this is your f of x equals the cube root of x. This would be, I'm going to say g of x equals x cubed. See how they are reflections over that line? If you were to reflect it, here you be. If you reflect it, here you are. This looks like the lightsabers being twisted together. I think my mind's probably just in that mode because first hour they were drawing post-it notes of Star Wars.
Star Wars is amazing. Because Chris is not in Star Wars.
Oh, son of a gun. She said the G word. I hope you guys could hear that. This was on the floor. And then I just tapped on the microphone.
I listened to the video. I'm going to hear you say that.
I know. I apologize. I should have said earmuffs. Put your earmuffs on. Okay. As we were. On the back. Miss Whipple got really angry today. Do you guys ever work with little kids? She called me stupid.
Dude, I have 3 little sisters.
No.
Every day.
That.
One tried to call my bed last night.
Tried to do
Go
what?
away.
One tried. What did she? Oh, crawl in your bed.
Because I have a big bed.
Yeah.
So the little one, she's like 6.
Yeah.
She wanted to have a sleepover. I was like, no, go away. I want to sleep.
You said no, it's a school night.
Yeah.
That's right. All right, so now we're going to talk about transformation. So we need to recall all the things that we've learned about transformations this year. We've been working on that a lot. So before, when we had polynomials, you normally had parentheses, right? And if something happened inside the parentheses, that was what type of transformation? Yes, horizontal. So now, if something is happening under the radical, that's going to be some kind of horizontal transformation. Okay, it'll be a translation if it's added or subtracted, and then if it's multiplied, then you're going to have a compression or a stretch. Okay, if it's outside the radical, then it's some kind of vertical transformation. Notice I'm saying transformation and not translation. So the transformation includes the translations and the stretch and compressions. Okay, so in terms of describing the transformations, keep that in mind. We also have reflections, which we'll talk about. We are going to graph the function. So we just said that whenever we're graphing, we're going to need a table. Okay, and if it's a square root, Tyler, how many points do we need?
4.
Good. And then Chris, if it's a cube root, how many points do we need?
5.
Good. Okay, so this one is a square root. So when I make my table, I am going to have 4 points on it. Now there's a couple different ways that you guys can think about the graphing. Also, when you do the domain and range, we are going to do that in set builder notation. All right, so first let's talk about the transformation. So I do have one that's under the radical, so I know it's going to be horizontal. So I have x minus 3. Lauren, what kind of transformation do you think that is?
A horizontal translation to units, right?
Good. So a horizontal translation 3 units right. Because remember, if it's underneath or inside the parentheses, it's deceiving. If you see the minus 3, it's really you're going 3 units to the right. Okay, and then is there anything else that's different from the parent function? Nope, so then this is our only transformation. Okay, so we need to have that part. Okay, now let's talk about what this means. If it's horizontal, is that going to affect our x or our y axis?
X.
Okay, good. So 3 units right means you are going to be adding 3 to the x values, because horizontal is your x-axis. So like I said, there's a couple different ways that you can do this. One way is to use your parent function chart, and you can use that to do the new one. So with the parent function, for the square root, we had 0, 0. We had 1, 1. The square root of 4 is 2. The square root of 9 is 3. So if we wanted to translate that to f of x, then all we would have to do is add 3 to the x's. So if I added 3, 0 plus 3 is 3. 1 plus 3 is 4. 4 plus 3, 7. 9 plus 3, 12. And then your y's are going to stay the same. I'm just really going to prove that to you. So if you were to plug in 3 into your equation, okay, then you would have the square root of 3 minus 3, which is just the square root of 0. What's that going to be? What's the square root of 0? 0. If you plugged in 4, 4 minus 3 is 1. The square root of 1 is 1. 7 minus 3 is 4. Square root of 4 is 2. 12 minus 3 is 9. Square root of 9 is 3. Okay, so the y's remain the same because the only thing that we had was something that affects the x-axis. So now we can go ahead and we can graph that. What questions do you guys have for me about that method? The other thing that you could do is you could ask yourself, what would I plug in for x that would get me 0? So we'd know if we plugged in 3, 3 minus 3 would be 0. That's what you could do to get the next x. What do you plug in to get 1? 4 minus 3 is 1, so I'd plug in 4. What do you plug in to get another perfect square? And then you could just keep going like that. Okay, what would you plug in to get 4? Oh, 7. All right, so now we're going to graph this. So I have to go out to 12. Do I have enough space to do that, or am I going to have to go by 2s? Going to have to go by 2s? Lies. I can fit 12 on there, couldn't I? Okay, so I'll do that then. You sit on a throne of lies. Do you guys know where that's from? Yes! What a good day to think about Elf with all the snow. It's when Santa comes and it's like, you're not Santa.
We're talking about Elf.
Yeah, the movie Alf with Will Ferrell.
You're not Santa Claus.
Yeah. You sit on a throne of rocks.
That movie made me try spaghetti and.
No.
I mean, it's not a bad.
It's not that bad. I'm gonna be completely honest.
I mean, that sounds gross. And coming from me, I like to dip my potato chips in ketchup or mustard because Panera doesn't have ketchup, so I like the plain potato chips and mustard.
Little sister dips Cool Ranch Doritos in ranch.
Oh, does she?
I don't think any.
I don't think I'd like that. You guys, regular potato chips are pretty much like French fries, so just a little bit of ketchup. That is very European.
I've done that. I've done the potato chips and ketchup before, but mustard,
What's a girl to do when she's at Panera?
just don't get the chips.
No, Macy, you always get the chips.
I don't like the chips there.
You don't? They're so
I get like
good.
the little piece of baguette.
Yeah, the
I
baguette.
like it.
I
And
gotcha.
I like some butter on it. It's delicious.
But if you get a sandwich,
I still do that. I get grilled cheese.
I still do. All right, let's try the next one. B.
Mustard on.
For those of you joining us at home, I hope we're entertaining you today. Please subscribe and like my channel. All right.
Subscribed and I have notifications turned on.
Oh, let's do the domain and range.
Today's just a weird day. Everyone just wants to be home.
I know. All right, so for the domain, we're going to stick to using that the radicand has to be greater than or equal to 0. So the radicand is what's underneath the radical. This time, underneath the radical, I have x minus 3 is greater than or equal to 0. So when I add 3 over, I'll have x's, this is a 3. I'll have x's greater than or equal to 3, so x such that. There we are. Hey, and you can see that my graph also models that because I did use the parent function, and 3 is the lowest value you can plug in. And then for the range, okay, in terms of y values, what's the lowest y value? 0. And then is it going up from there or down? Up. So then y has to be greater than or equal to 0. Now, if you do have some kind of vertical transformation, then that is going to change. All right, so what I want you to do for part B is I want you to first start and write out what the two transformations and then you can check in with your EP, elbow partner, and make sure that you guys have the same thing.
I've seen that. Once when I was like little, I was eating mac and cheese and had like a hot dog and ketchup on the side, and it would accidentally mix. It wasn't that bad. I wouldn't seek it out. I get them confused, okay? It's like my when I'm driving, I go. Wait, is this the right side? Yeah, what side am I? Yeah, the baguette's good. Once we're
It's just a force of habit by now.
Tori walks over and she just has like this 3-foot baguette. I'm like, Tori, and she's like, what?
Christopher.
Like,
Hello. Good evening.
side. I'm like,
Exactly.
this makes sense. But in like a lot of days, like I haven't had it in so long. Let's do it again.
Once you've checked your transformation, go ahead and graph it. All right, so Macy, tell me what one of your transformations was.
I said a horizontal translation 2 units to the right.
Good. Okay, so horizontal translation 2 units to the right. Okay, and then Cole, what was the other one?
Vertical stretch by factor of 2.
Good. Vertical stretch by a factor of 2. Okay, so like I said earlier, there's a couple different ways that you can do this. You can use the parent graph and you can do the shifts from there based on these two transformations. So if it's a vertical stretch, that is going to affect the x or the y. The y. So if it's a vertical stretch by a factor of 2, you are going to multiply the y coordinates by 2. If it's a horizontal translation 2 units right, we just had that up here. So we are going to add 2 to the x values. All right, so let's look at the parent function. So for the parent, the cube root of x, your x and y were -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. So if you're gonna do your transformation to g of x, okay, all we have to do is add 2 to the x values. So -8 plus 2 would be -6. -1 plus 2 would be what? 1. Okay, 0 plus 2, 2, 1 plus 2, 3, 8 plus 2, 10. And now we can find all of the y coordinates just by multiplying them by -2. Again, I'm just going to show you how these are going to work out. So you could just do -2 times 2, which is -4, -1 times 2, which is -2, so on and so forth. If you plug these values in, so if I plug 2 into my equation, I have the cube root of 2 minus 2. 2 minus 2 is 0. The cube root of 0 is 0. 2 times 0 is 0. If I plug in 3, 3 minus 2 is 1. The cube root of 1 is 1. 1 times 2 is 2. Okay? If I plug in 8, or not 8, 10. If I plug in 10, I'll get 8. Cube root of 8 is 2. 2 times 2 is 4. All right, and then after you plot that, will you guys do your domain and your range, please? So I'm going to go to 10, up 1, 2, 3, 4. 1, 2, 3. 1, 2.
What?
And then I want you guys to think about, too, what does the vertical stretch of 2 mean?
It's getting taller, slimmer.
If it's being stretched vertically, it's like you're pulling it apart. So now can you see how the spacing between these is further apart? Okay, so again, you're going to be curving them. And then you're going to be curving this. All right, and then Rhea, what did you write for your domain?
All real numbers.
All right. X such that X is an element in the real number set. You guys have that in set builder notation?
Yeah.
Awesome. And then the same thing with Y. Okay, we're ready for the grand finale?
No.
Why not?
Let's do it. I'm slow. I'm tired. I wanna go home.
But you have this one done already? That's okay. All right, so the last one is f of x equals, just turn it off, please. Do you have an alarm set for something? Okay, so we're going to start with the transformations. What's one of the first things you guys notice about the equations?
Negative.
Yes. Now the negative means it's a what? Reflection. Right? Now we have to decide what it's reflecting over.
The x-axis.
How do we know it's the x-axis?
It's on the outside.
Yes, good. Okay, so the negative is telling us that there is a reflection. Okay, it is over the x-axis. Remember XOXO? So perfect with Valentine's Day coming up.
No.
So perfect for Singles Awareness Day coming up. That's what we called it when we were in high school.
Yeah, that is.
Okay, so it's a reflection over the x-axis because the O is XO. The O stands for outside. Okay, now when you think about how this affects your graph, remember that with the reflections, it affects the opposite. So if it's over the x-axis, it actually affects the y. We'll talk about that. And then you also have a horizontal translation for units. And again, this is to the right. If it was plus, it would be to the left. Okay, and then the last one, Gigi, what's the last one going to be? What do you think?
It's
Cam.
full translation or unit up.
Yes. That was very aggressive. Please do not.
Turn your look at it. Gosh, Cam, why are you gonna be so aggressive? You look at Chris every day aggressively. I want to hear it.
Yes, you both do.
I will keep all do something. Bullying me right now. What are you talking about? You said you were gonna push me down the stairs. I don't even remember. Swim stairs? If so, I mean, stop. Wait. Which stairs?
Gentlemen.
You're being recorded.
Oh, we're being recorded?
Yes.
Cool. I'm
Hello.
okay with that. Wait.
Okay, so I want you to write what each one is going to affect here. Okay, so you think you know, does it affect the X or the Y?
What?
I feel insulted.
Yeah, you feel violated, don't you? That's how Gigi felt.
A little bit.
She kept her cool
But
under
also
pressure.
makes me want to do it again.
What has this turned into?
This is how you know everyone needs a day off. We are just-
I'm fine. I'm fine.
I can't believe Ethan missed a fun day of math.
I would close the intense day of math.
Should I call it?
No, it's all you.
That's so scary. I was
That's scary.
All right, so remember we said that if it's over the x-axis, that actually affects the y. Okay, so it's switched, and it's going to be the opposite of y. So the negative is applied to the y. The horizontal translation, because it's horizontal, it affects the x value, so you're going to add 4. If it's vertical, it's going to affect the y values, so you're going to add 1 to your y values. Again, you could pick values that you know are going to make a perfect square underneath. So, like, what would I start with if I wanted 0 underneath the radical? 4. Cam, really? Put it away. I'm doing my best to entertain you, and this is the kind of thing that you get.
I wanted to share my entertainment.
Are you not entertained? All right, so if you plug in 4, 4 minus 4 is 0. The square root of 0 is 0. The opposite of 0 is 0. 0 plus 1 is going to be 1. Because you're doing 0 plus 1. Okay, if you use the parent function, I'm going to go over how you could do that too. But I plugged in 4 because I knew that that would be a perfect square underneath the radical. The next one I'd want to get, Ian and Christopher. The next
8.
number I'd want to plug in is what?
8.
We are going to plug in 8. Which one would I plug in before 8?
Oh, 5.
5, because 5 minus 4 is 1. The square root of 1 is 1. So this would be the opposite of 1 plus 1. Negative 1 plus 1 is 0. Okay, so you could just plug them in that way. So if with 8, it would be the square root of 4, which is 2. Negative 2 plus 1 is negative 1. Okay, and you could keep going that way. Or you could take the original, okay, the square root of x, which remember is 0, 0, 1, 1, 4, 2. Square root of 9 is 3. And then what you would do for the x values is add 4. For the y's, you'd have to do the opposite of y first. And then you would add 1. Okay, so if you did the opposite of y, you would, opposite of 0 is 0. 0 plus 1 is 1. Opposite of 1 is negative 1. If you add 1, you'd get 0. Opposite of 2 is negative 2. Plus 1 would be negative 1. Opposite of 3 is negative 3. Plus 1 would be negative 2. So that's how you'd get your new y values. Okay, to get the x values, all you'd have to do is what?
Plug in number.
Well, and then if you use this, you would just add 4. So 0 plus 4 is 4. 1 plus 4 is 5. 4 plus 4 is 8. 9 plus 4 is
13.
aggressive. Do not be aggressive. All right, and then, like I said, here you get negative 2. And now we are going to graph this, and I actually went up one more so I would just get a better picture. So if I did do the next value, that is 16, if I added 4, I would get 20. And yes, it would be negative 3. You can see the pattern that's happening here. Okay, and then let's go ahead and draw our grid. I'm going to go by 2s. Oh, when Ethan watches the video, he'll get to hear the fun day of math.
Ethan, we miss you.
Shout out to Ethan.
Hi, Ethan.
He's gonna be like, what's happening?
We just won't tell him that we put this in here, and then we'll see if he really watched the video.
Then when he comes back Tuesday, we'll be like,
Subtitles for this
Two,
will show
sorry,
you down
2,
his
4,
stare.
6.
Ethan, if you're watching this, tell us star on
Yeah,
Tuesday.
Ethan, if you're watching, the code is star.
The code is send help, please.
the code is fun day of math.
You just said on a
I tried to do a flipped classroom for a little bit. Yeah, Rhea and Sarah, you guys were there, and so I would put like a little code in the video,
I remember that.
and like people were missing it, and I'm like, you didn't listen to it. You're like, oh, I thought it was totally cool if we listened to this on 1.5 speed and didn't listen to anything that you were saying. No,
Are you okay?
no, Cheryl, I'm not okay.
You need to talk about it.
Because I am.
That's not how this works. That's not how any of this works.
Wait, can I be Karen instead?
I created Cheryl today, who is probably related to Karen.
I want to be Patricia. No, you're Cheryl. No. It's stuck now. Gosh darn.
Ethan, all your tests write, what was it?
Cheryl. I actually might do that.
Please. All your notes.
Yes, Doug, it is Valentine's Day today. Thanks for remembering.
feel like Keanu Reeves about to cry while eating steak. What the heck?
Why does he cry while eating steak?
Has no one seen that video? Oh, yeah.
I've seen that video.
No, Cheryl, we haven't. We've been too busy doing our math homework.
Having a fun day of math.
Watching the math video. He's eating a steak and listening to the noises of the animal he's eating and starts crying.
Oh, that is really sad.
That's not a joke.
All right, now we're going to do the domain and range. So for your domain, again, you can always take what's underneath the radical and set that greater than or equal to 0. So for the domain, if you say that x minus 4 is greater than or equal to 0 and solve that for x, that's going to give you your inequality.
4.
And then your range. Now, for your range, let's look at your y value. So the highest y value is 1, and then, yeah, Rhea, how is this going to change for the range? Yes, so now it has to be less than or equal to because all the points are below, and they're going to negative infinity. Okay, so all points are at or below 1. Okay, and then here is what you're going to be working on. So this has to be on graph paper. And then just like these, when you have them, this is what I'm looking for. You describe the transformations, you're writing the domain and range, and then you have specific points. So this I am going to be checking on Tuesday for a grade. So I'm going to give you time to work on this now.
Oh yeah, the slideshows.
No.
Slideshows.
Sharon wants to introduce itself.